Hey there, this is Mr. Alexander, and today I want to talk to you about solving quadratic equations. In other words, getting the variable, which is usually x, by itself for quadratic equations. Now, we're going to do that today by factoring. And if you don't remember what factoring is simply taking a quadratic equation that looks like this and writing it in terms of its factors, which looks like this. The reason we're going to do that is because once you have factored the quadratic and set it equal to 0, then you can simply take the two factors and set them individually equal to 0. For instance, here we could take this k plus 1, set it equal to 0, and the 4k plus 5 and set it equal to 0. At this point, we can solve for k by solving how we normally solve for x. So if you subtract 1 on both sides, this would be k equals negative 1. And then if you subtract 5 from both sides, you'll get 4k equals negative 5, and then you get k equals negative 5 over 4. So the two solutions are k equals negative 1 and k equals negative 5 over 4. Every quadratic has the potential to have at least two solutions. Exactly two solutions. Sometimes it'll have 0 solutions, sometimes it'll have 1 solution, but most of the time we're talking about 2 solutions. So it can become a little bit more complicated when you've got an equation like this. N squared plus 7n plus 10. To factor that, I usually like to think about it in terms of this. We need to know a times c, and we need to know b. And in this case, the a is the number in front of the n squared, the b is in front of the n, and the c is on the very end right here. So a times c is going to be 1 times 10, and b is going to be 7. What I'm looking for are two numbers that multiply to 10, but also add to 7. Two numbers that multiply to 10, but add to 7. And the numbers that pop in my head are 5 and 2. Because those multiply to 10, but also add to 7. So, if I was going to factor this equation up here, I could rewrite it as n plus 5 times n plus 2. And at this point, I'd want to take each of these factors and set them equal to 0. n plus 5 equals 0, and n plus 2 equals 0. So when I solve for n, my two solutions are negative 5, comma, negative 2. And that's the solution to that quadratic equation up there. So let's do another one like that. N squared plus 3n minus 18 equals 0. We want to know a times c and b. A times c in this case will be 1 times negative 18, and my b is positive 3. 1 times negative 18 is negative 18, and 3, of course, is just 3. So I want two numbers that multiply to negative 18, but add to positive 3. Two numbers that multiply to negative 18, but add to positive 3. In my head, I'm getting 6 and negative 3, because 6 times negative 3 is negative 18, and 6 minus 3 is positive 3. So when I factor this equation up here, I'm getting n plus 6 times n minus 3 equals 0. You would just want to set each of those individually equal to 0. n plus 6 equals 0, and minus 3 equals 0. So when you solve for n, you've got negative 6 and positive 3. Those are the two solutions. These come in varying degrees of difficulty. The a is not always 1, and when the a is greater than 1, things can get a bit more complicated. So why don't we address one like that? Like this. 25x squared plus 20x plus 4. The process is exactly the same. A times c and b. In this case, it's going to be 25 times 4 and 20 for b. Well, 25 times 4 is 100. So we want two numbers that multiply to 100 but also add to 20. And the ones that are popping my head are 10 and 10. Like that. Now, when the a is not equal to 1, we got to think about this process just a little bit differently. We're still going to write our factors and set them equal to 0. So we still got this x and this x. And we're still going to do plus 10 and plus 10. But you may have noticed that I wrote those 10s a little bit higher, because now we need to take the a value, which in this case was 25, and we need to write it in 3 places. We need to write it here, here, and here. And if you work this out algebraically, if you were to FOIL this and multiply it by that, you'll see that these two equations are the same. So when we've got it set in this form, we can reduce that fraction a bit. So I'm going to go ahead and do that. 25x plus 10 over 25, if you divide both the top and the bottom by 5, that's going to give you 2 over 5. And x plus 2 over 5 equals 0. Well, at this point, we've got our two factors in this number out front. We're going to take everything and set it equal to 0. Everything that makes sense to set it equal to 0. Would it make sense to set 25 equal to 0? No. In fact, we're just going to ignore that. We're going to take the two factors and set them equal to 0. And you'll notice that they're both the same. So this is one of those situations where there's only one solution. In fact, that x, the solution, is negative 2 over 5. Or 0.4 if you prefer, as a decimal. And so that can happen. Sometimes quadratics have one real solution or 0 real solutions. And this is just one of those cases where it has one real solution. So I don't think that's particularly easy, so we probably ought to practice it a couple more times here. So here's another one. And I just kind of stepped it up a notch. And on problems like these, you simply need to remember that in order to solve it, it needs to be equal to 0. And I'd prefer to get the 0 on this side. So I'm going to add 30 over here, and I'm going to subtract 11x over here. I'll make that 5x squared minus 55x, because I subtracted the 11x over there. Add the 30 to get 150 equals 0. Now, I'm looking at this, and when I do a times c, I'm going to end up doing like 5 times 150. I don't particularly want to do that. But I do notice that these all have a common factor, which is 5. I'm going to factor out that 5. I'm going to make this 5 times x squared minus 11x plus 30 equals 0. Now this looks like a lot easier to factor than that. So from here, my a is 1 and my c is 30. I'm simply looking for two numbers that multiply to 30, but also add to negative 11. So two numbers that multiply to 30, but add to negative 11, that sounds like negative 5 and negative 6 to me. So I'm going to factor this as x minus 5, x minus 6 equals 0. Now I'm going to take all my factors and I'm going to set them equal to 0. And I can just ignore the 5 because I can't really set 5 equal to 0. That doesn't make any sense. So I'm going to say x minus 5 equals 0 and x minus 6 equals 0. And that means that x equals, and that'll be positive 5 and positive 6. All right, so let's look at another one now. It looks like it might be challenging, so let's talk our way through it. Again, we need to have a 0 on one side in order to solve it. So I'm going to add the 3 and I'm going to add the 5x squared. When I add 5x squared over there, it's going to give me positive x squared minus 8x plus 3 is 0. So that's what I'm left with. Here's a type that we haven't talked about yet, when you don't have a c term here. Still ask yourself the question, what do they have in common? It looks like they both have an x, so I'm going to factor out an x there to give myself x times x minus 8 equals 0. And at this point, I've got my two factors. It's just this one is x plus 0. This one's x minus 8. I'm going to set them both equal to 0. So x equals 0 x minus 8 equals 0, meaning that x equals 0 and positive 8. That's the solution there. All right, so let's talk about some other ones. This one looks like it could be challenging. Right here. 35x squared minus 22x plus 7 equals 4. Well, we need a 0 over here, so I'm going to just subtract the 4 over. 35x squared minus 22x plus 3 equals 0. And to solve this, to factor it, I need to know two things. I need to know a times c, and I need to know b. A times c is going to be 35 times 3, and b is negative 22. 35 times 3 is 105. So I need to know the factors of 105 that add to negative 22. Well, since the b value is negative, I know that both of these factors have to be negative. But let's go ahead and think about the factors of 105. And here's the easiest way to think about it. If you go to your calculator, and you go to y equals, and you do 105 divided by x, then what you can do is go to the table. It's going to show you all the factors, like 1 and 105, 3 and 35, 5 and 21. Now we want the ones that add to negative 22. Now when you add these, none of these are going to add to 22. So I actually need to look at the negative factors. Okay, negative 1 plus negative 105, that's not negative 22. Negative 3 plus negative 35, that's not negative 22. But when I go up to negative 7 and negative 15, that does add to negative 22. So those are the two numbers that I need. Negative 7 and negative 15. So I'm going to rewrite the equation now with my factors. I've got my x, I've got my minus 7, but I know I'm going to write it as a fraction, so I'm going to keep it nice and high. I know it's going to all equal 0. And I'm going to take the a value, I'm going to write it 3 times. 35, divide by 35, divide by 35. So I can take the two factors and set them equal to 0. X minus 7 over 35 equals 0, and x minus 15 over 35 equals 0. So my solution is simply x equals positive 7 over 35, comma, 15 over 35. But hopefully you've recognized that we can reduce both of those fractions. 7 over 35 becomes 1 over 5, and 15 over 35 becomes, let's see, you take a 5 out of both of them, that's 3 out of 7. And so this is probably the hardest problem you're ever going to see. So if you can handle this, then you can handle solving by factoring. Let's go from the hardest to the easiest. Problems like this, these are called the difference of two squares. And the way you recognize them is by recognizing perfect squares. Perfect squares are like 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, and so on. 64 was actually the next one here, because that's 8 times 8. So here's what you do. To factor it, what's the square root of x squared? Well, that's just x. What's the square root of 64? Well, that's just 8. Put a plus and the minus in there, and you're golden. X equals negative 8, positive 8. The way you recognize the difference of two squares is there's only two terms. It's a binomial. Both of them are perfect squares. Same thing here. Square root of 4. Square root of x squared. Square root of 121. Plus and minus. X equals positive and negative 11 over 2. And that's it. Thanks for watching this video on factoring. I hope it was useful.